Hello everybody, welcome to the Python course. In the previous part, we have covered introduction to Numpy. So we have covered creating arrays using Numpy. We have also seen how we can generate different types of arrays using Numpy inbuilt methods. Right? So this operation we have seen, and we have also seen why Numpy is better than our Python list. Right? So we'll continue this module in this lecture also, and today we will see the various operations on arrays, and we will see the index slicing and iteration, right? How we can modify the elements of the Numpy array, and we will also see some mathematical and statistical methods that can be applied on these Numpy arrays. So let's start. So I've already opened up my Anaconda navigator and we'll start with the Jupyter notebook. So we'll continue in the same notebook which we were following in the previous lecture. Okay, so I'll go to documents, then GitHub projects, then Python trainings, tunic, in which we have started with our Numpy. So in this part we have already seen how we can create a Numpy array, right? We can have a list inside our Numpy array, so that can be converted into a Numpy. Then we have checked this type, that is numpy.nd array. So we have also checked the shape by using the shape attribute, and we can create a Numpy array of only ones with the specified shape, right? That is 5x5 with all the ones in this array. Then similarly we could also create np.zeros by using np.zeros method, right? And we can check the data type of a Numpy array by using our attribute, that is .dtype. And we have also seen the typecasting, that is conversion of one data type to another by using the asType method. And here we are trying to convert the data type of an array to numpy.float, right? So here we could have our list, and we could mathematically perform two operations, that is array1 plus array2. So this operation is being done on individual elements, right? So first I showed you how we can do the same operation on the list, but lists don't do the element wise operation. It simply is concatenate the list 1 to the list 2, but here we can do the element wise operation. Similarly we could perform addition, multiplication, subtraction, division. Also we could do our scalar multiplication or matrix multiplication, we can see that. Then we used np.linspace method and try to convert try to produce an array which is of equally spaced ranging from 2 to 10, and the ret step is equal to true, which means that it has been incremented by 0.8, right? Then similarly we have the .arrange method, in which we could have the range from, we can specify the start range to the end range, and we could also specify the step parameter, right? Then we could have random values, right? And then we have log space, right? So similarly we could generate these arrays by using different methods and using different functions. Then we have seen that why Numpy array is faster than your list. We have created a list and we try to calculate the sum of elements inside this list, and it takes us 19.3 microseconds, right? And when we try to do the similar operation by using numpy.sum, it took us 6.19, right? So this means that numpy are really very much faster than our list operations. And then we also calculated the size in bytes, that is memory usage of our list and memory usage of our numpy array, right? And it comes out to be a huge difference, that is approximately 3 times smaller we could store the size of a numpy array, right? So we'll continue this further, and in this part we will look upon our other methods, reshaping, then we'll see numpy operations, then how to access elements from an array, then we'll see how a subset of an array could be retrieved from a numpy array, right? Then how we can modify that subset, or we wanted to modify all the operations, right? So this, in today's lecture, we will see all those things, right? So the first method is your reshape. So remember, in the previous lecture we have discussed about the arrange function. So arrange gives out to be a 1D list, right? So it does not give us the 2-dimensional or a 3-dimensional array which we want, right? So what does the reshape method does? It recasts an array to a new shape without changing its data. For example, there are 9 elements starting from 1 to 10, but 10 is not included here, right? So total of 9 elements are there. So we could reshape into 3 cross 3, that is in multiples, right? So 9 could have a multiple of 1 or 9 or 9 or 1 or 3 cross 3, right? So these are the multiples of 9, right? So we could reshape in this manner, right? So if we are not the multiples, then it will give us the error. So let us try to see this part. Okay, so I'll run all these cells in this part. So let us try to create an array numpy dot range starting from 1 to 10. Then we are trying to reshape into 3 cross 3. Reshape, right? So this has reshaped into 3 cross 3. So when we check the shape, it is 3 cross 3, right? So for example, I give it 10 elements and I wanted to reshape into 3 cross 3. It will result me in error, that is cannot reshape array of size 10 into shape of 3 cross 3. So one thing to remember, that it should be a multiple of what we are trying to reshape it. For example, I am trying to create into 5 cross 3. So it could be 16, right? So now we have 5 cross 3 shape and it is 5 cross 3, right? So if I do it 1 cross 7 and 2 cross 3, so it will give us 2 cross 3, that is 6, right? Right? So these are the 4 elements, these are the 9 elements, so sorry 8 elements. So I could also shape into a 3-dimensional, right, by using 2 cross 2 cross 2, that is 4 2s are 8, and if I try to shape it, so it is basically a 3D array, right? So we have also seen 3D array, so now it is a 3-dimensional array, right? so you could check its shape. So it is 2 cross 2 cross 2, right? So shape could be n dimensional because it is an nd array, so you could have any dimension into it, right? So this is how your reshape method works. And if you wanted to have an array and reshape it, so you can do it by using your reshape method, right? Okay, so this we have already seen. So we have created an array and it returns us the shape, right? So right, okay, so then we have the some addition operations. So that are the inbuilt operations which Numpy has provided us, right? So we can also do it by using your plus operator also, but it is highly recommended if Numpy has given us some mathematical operations, so we do that operations, right? Also there are various parameters included in it. Suppose for example, let's say axis is there, so we wanted to take the overall sum, or we wanted to take the sum of all the rows or sum of all the columns. So that way we could specify the axis parameter and set it flag as equal to 0 or 1, and correspondingly we could get the sum, right? So sum returns the sum of all array elements or sum of array elements over a given axis, right? So we have two parameters in the sum function, that is array, and we specify the axis, right? So if we don't specify any axis, so it is by default axis is 0, and it will try to calculate the sum across all the columns, right? Okay, so let us try to see, right? So if we wanted to try to calculate the sum all around the column, then we specify axis is 0. If we specify axis equal to none, so it will give us the overall sum. So let us try to see this. So we have our array, right? So I just make into, so let's take a 2 cross 2, and here I will take 5, right? So 1 2 3 4, right? So let us deal with a simpler one. So if I wanted to calculate sum of all the elements in the array, so that function is array.sum. So it will give us the 10. 1 plus 2 3, 3 plus 3 6, 6 plus 4 is equal to 10. If I wanted to calculate the sum axis equal to 0, right? So I could specify here numpy.sum, and here I could specify array because it take two arguments, one is the array and other one is the axis, right? So what it is trying to do is it is trying to calculate the sum across the columns. So don't confuse with the rows or the columns, right? So axis 0 is basically you are trying to calculate the sum across your columns, that 3 plus 1 is 4 and 4 plus 2 is 6, right? So it will give you across columns, right? But if you try to specify here x is equal to 1, then it will try to give you the sum across your rows, that is 1 plus 2 is 3 and 3 plus 4 is equal to 7, right? So this is the difference between your x is 0 and x is 1. So remember always, columns equal to 0 we need to specify x is equal to 0, and for rows we need to specify x is equal to 1, right? Okay, so this has resulted in us in the giving us the sum across all the columns, right? And sum across all the rows we have specified by giving sum across all the rows, right? Okay, so then we have another operation, that is numpy addition. So it performs element wise addition operation between two arrays. So syntax is similar, so to our previous syntax, that is numpy.add an array1 and array2. We specify both the arrays and we want a element wise addition between these two arrays, so that could be done, right? So here we take two arrays, right, and I take another array underscore 1 equal to np dot range 5 to 10 dot shape 2 cross 2, right? So this is your array 1 and array 2. So np dot add array and array 1, right? So here we wanted to add both the arrays, right? So this one were our array 1 and this is our array. So 1 2 3 4 5 6 7 8. So only the element wise operation will occur. So 5 plus 1 is 6, 2 plus 6 is 8, 7 plus 3 is 10, and 8 plus 4 is 12. So this is how your array operation will work in case of your addition, right? So this is how your numpy add operation works, right? Element wise operation occur. Similarly, we can perform the element wise multiplication also between these two arrays, right? So syntax is same, right? So we need to specify the np dot multiply a and b. So there is a 3 cross 3 array, this is also 3 cross 3 array, and the resultant will be also 3 cross 3 array. So it takes the element wise. So 1 into 11 is 11. So 2 into 12 is 24, and 3 into 3 is 13 is equal to 39. So this is how your element wise operation will occur in all the elements, right? And then we'll get the resultant. So similarly, we have the other functions such as numpy dot subtract, numpy dot divide, and numpy dot remainder. So these are some of the operations. You can try it out, right? The basic logic and the basic functionality remains same. So you need to define two parameters, right? So you need to define your axis also, you need to define your arrays also, right? Okay, so now we'll move to the next part, that is how we can access the components of an array. So this part is very much important, and it requires understanding, right? So how the individual elements of an array can be accessed using your index number, right? So this is your index axis along your columns, and this is your index 1 along axis equal to 1, that is your rows, right? So we wanted to extract the element with the 0, 1 from A, right? So 0, 1, right? So 0 column 0 this and first, right, first column and 0 row, right? So this is how you can replace it by using your 0, 1, right? Okay, so here, okay, so this I'll create this example. So array underscore 3 equal to np dot arrange 1 to 10 dot the shape 3 cross 3, right? So in this array underscore 3 we wanted to have 0, 1. So 0, 1 is your 2, right? Right? So 0, 1. So 0 rows and first column, right? So remember, indexing always starts from 0, right? Whether in case of your rows or whether in case of your columns, right? So we wanted to extract the elements from the second and third row of an array, right? So what it says is we wanted to extract the element from the second and third row of an array. Second and third row of an array, right? So first of all, we try to understand how we can extract only the rows, right? So that can be done by using your 0. So this is your 0th row, right? If you wanted to access the first row, this is first row. If you wanted to access the second row, this is your second row, right? So this is how you can access your 0 row, first row and second row, right? Now in this part, if I specify I wanted to have the elements from the first row, right, and inside that I wanted to have the second column, right? That is first row. This is index start from 0, so this means this is the first row and your second column. So this 5 will come, right? So here the logic or the principle which is being followed here, it is that here you specify the rows, separated by a comma you specify the columns, right? So okay, so let us revise again. For example, you wanted to have the 0th row, so this can be easily done by your using u0. Okay, here also we are talking only about the rows now, then we'll talk about the columns, and then we'll talk about the together rows and columns. We only wanted to have the 0th rows, so that can be done. For example, I wanted to have 0 to 1, 2 rows, 0 and 1, so that can be specified by using 0 to 2, right? Because the slicing works from 0 and goes up till the end and end minus 1, right? So it started from the 0th row and ended till the first row. Second row is not included. If I wanted to have all the part, then I could specify all. So this is basically the slicing which we have done earlier also, right? So this is how you can do it. For example, if you wanted to have your rows starting from first and till the ending, so that it will come 4, 5, 6, 7, 8 times, right? So in the first part we have specified this row, so we are only concentrated about the rows, right? Now we leave this part and now we'll concentrate on the columns part. For the columns, you only want your columns, so here you can see this, say that I want the columns 1, 2, 3, right? Here you are saying that I want all the rows, but the columns I want only 1, 2, 3. So 1, 2, 3. So this part 2, 5, 8, 3, 6, 9 will come. So this comma is being separated, that what rows you want and what columns you want. Here, if you want to have a slicing here also, 1, 2, 3. So now only this part has come, right? So this is how it works. So here in this part you can specify your rows, and here in this part you could specify your columns, right? Okay, so this is how we are trying to do a subset. For example, this is a 3 cross 3, so we wanted to extract a 2 cross 2 subset array from the original array. So here we could specify it from 0 to 2. We want 0 to 2 rows, 0 to 2, that is this both the rows we want, right? In this both the rows we only want 0 to 2 columns, that is 0 to 2 columns, not the third column we don't want the third column. So 1, 2, 4 and 5 will come, right? So here we have specified here. So this is how you can create a subset of array, right? And if we wanted to update a specific value that is being residing at a particular position, that also we could change it, right? For example, we wanted to change 1 to 12, or we wanted to update the value or update all the values of a sub array to a specific value, that we could easily do, right? For example, here in this array 3, so I could specify array underscore 3 equal to right. So this array, or I could simply specify here array equal to 0, right? So now this part has become 0. right? So first we are trying to extract the subset part, and then we are replacing or modifying them, right? So this is how your indexing works in the case of your numpy array. So this is your row, and in row also you could have a slicing part, this separated by a comma, and here you wanted to have a slicing in case of columns also, right? So this is your rows and this is your columns, right? So this is how you can replace the value and first try to subset, right? Okay, so now this is your graphical representation of how we could have this your array slicing. So this is your 3x3 matrix. In this part we want 0 to 2 rows, so this and this will come, right? And the columns, we want the columns 1 to end, that is 1 to end. So this part will only be sliced and its shape is 2x2. In this part we have array 2, only the last row will come. So here you see that this is your 1D array. So this is 1D array. But if you are trying to have it, right, your columns also, right? So this is your 2D array, 1x3. Right? So this is basically your 1D array and this is your 2D array. So if you don't specify anything after the comma, that could be easily represented as 1D array, right? Similarly, we want all the rows and columns ranging from 0 to 2. All the rows, columns ranging from 0 to 2. So it is 3x2. We want only the first row, so this will come, and columns 0 to 2, right? So this modify helps in giving us 1D array, 1D, right? So similarly this operation also, slice from 1 to 2 and column 0 to 2, right? So we have 1x2, right? Okay. So the other operation is your transpose. Suppose you wanted to change or reverse the shape of an array, that is basically the opposite, right? So that you can do it by using your transpose method, right? So this is your 3x3 matrix, and we wanted to interchange your rows with columns and columns with rows, so that could be done by using a transpose, right? Interchanging of rows with columns and columns with rows. So now you can see that, so 147 was in your first column, so it has become your first row. 23200, right? So it has replaced by your second row. Second column has been replaced by your second row, right? Okay. So the next method is your append method. So what it does, it adds the values at the end of the array, right? So it is similar to your list append method. So we have your array and your what original array and what array you wanted to append it, and your axis, right? So whether we wanted to append it as a row or we append it as a column. But one thing you need to note it down, so the array which you are trying to append must be in the same dimension in the row or in the column, so otherwise it will result in your error, right? So here it is having a dimension of 1x3, right? So we have 1 row and 3 columns. So here we could easily replace it by using your append method, right? So np dot append, we need to specify array 3, right? Then we need to specify your array, what array we are trying to append, and the axis. Suppose I am trying to append 14, 16, okay, and I specify x is equal to 0, right? So the shape of this array is your 1x3, so it got easily appended in your append method, right? But if you're trying to append it across the column, so it will give you error that it is not having the correct shape, right? So it needs to be changed into, or you can do it reshape 3 cross 1. So first you need to convert it np.array right. So 14, 26 and 18 got appended across your rows. So this, you don't confuse it, because each element get appended across your rows. So this one element get appended in first row, second element got appended in second row, right, and third got in third, right. So this is how you can interpret it. So axis 0 means across columns, axis 1 means across rows. Okay, right. So here in this part, if we are trying to append it, so we need to reshape it by using your 3 cross 1, right. So this is how we do it. Then we have the insert method, in which we are trying to insert a element at a given position and axis in an array, right. So that can be done by using your insert method, right. So we have the array, we have the index position, and we have the values which are to be inserted across axis, which value to be inserted, right. For example, we wanted to insert a new array along the row at the first index position. So that could be done by using your index position. Right, so we have the array underscore 3 comma at the first position we wanted to insert, and what element we wanted to insert. So at the first index position, so this element got appended, inserted, right. Then we have the delete operation also, which removes the values at a given position and axis in an array. So delete also works in the similar way. So for example, we wanted to delete array, and we want to specify what element to be removed or its index position, right. First element to be removed, right, and we need to specify the axis also, right. So you might be wondering, so we have inserted this array in this array, but we haven't assigned it to array 3, right. So we are trying to only show it, right. So that's why this element will not be, or the operation will not be done in this array. So it is trying to give us, if I try to do this operation by using the assignment operation in your array 3, so then you can see that your array 3 will be having the element as 12, 34 and 56, which got inserted at the first index. Now you can delete it, and now you can see that it has got the desired operation, right. Similarly, right, so this we could do it by using your delete operation. Okay, so in this lecture, what we have seen reshaping of an array, you have seen your numpy operations, how we can access the components and subset and modify the arrays using your numpy operations, right. So thank you friends, thanks for watching.